Welcome back to math. Today we're going to be dealing with word problems. I know you hate word problems. Most people do. Don't feel bad. Let's see what we can do with them though, okay? 2 yards of fabric to make up 5 pillows. 2 yards of fabric to make up 5 pillows. How do we do this? Well, we could do this stacked tape diagram, which means how many yards of fabric are we going to use? 2. And how many pillows are we going to make?
5.
5. So we're going to need to cut this second box up into how many sections? 5, right. So the question is, we have 2 yards. We're going to divide it by 5 boxes, right? So how much is going to go into each? Well, this would be pretty easy because some of you have figured out, and I'll display it over here in the algorithm. What number goes on the inside of the box? 2. The 5 goes on the outside. Remember, the first number always goes on the inside. Okay, so how many 5s are in 2? I hope you said 0. You'd be correct. Then we're going to multiply 5 times 0. It's going to give us 0. And we're going to subtract it. It's going to give us 2. So our remainder is 2. And our unit is 5. So what's our answer? 2 fifths. So each box has 2 fifths. So each pillow is going to take how much fabric? 2 fifths of fabric. That would be our answer. Okay? Now if you don't understand this, we could just count up like the 2s. And we could say 2, 4, 6, 8, 10 over 5. Is that correct? If we added them all together? If we held up 10 fingers, what's 5 of those? How many 5s do we have in 10? We have 2. And if you notice, that's the number we started with. So that's how you can check it. You can check it with the algorithm. You can check it by putting them in the boxes and then counting them and adding them all together. But if you notice, 2 divided by 5 is 2 fifths. Let's go on to another one. The ice cream shop uses 4 pints of ice cream to make 6 sundaes, right? 4 divided by 6. Well, we could put our tape diagram. We have 4 liters of ice cream. Well, we're going to have to divide this up into 6. I like to cut it in half. And then I know I'm going to put 3 over here and 3 over there. So I'm going to put 2 more like that and 2 more like that. If we break this up into 6 boxes, what do you think our number is going to be?
4/6.
4/6 is correct. I'm going to put them below because it's hard to see them. What if I counted up all these 4s? 4, 8, 12, right? 12 plus 4 is 16. Then this would be 20, right? And then 24. That'd be 24 over 6. How many 6s are in 24? How many 6s are in 24? You would say 4, and that would be correct, which is the number we have up here. And it's the number we started with over here. That's how we could check too. So we did that correctly. I write rather large, so sorry, we're going to have to kind of move this around a bit. Jim has 2 2-liter bottles. Okay. Has anybody been to a, let's say, a birthday party and you've seen these big bottles of soda? Have you seen those?
Yeah.
Okay. So I'm going to draw them out for a reason. What are these? These are 2-liter bottles. Is that correct?
Yeah.
And we have 2 of them, don't we?
Yep.
Now let's see what this says. Has 2-liter bottles of soda, which will be put into equal amounts into 10 cups. How much will be in each cup? Well, first off, how many liters are we talking about here? What's our top number going to be in our tape diagram?
4.
What? I've got 2 liters here and 2 liters here, right? How many liters am I going to have? Yes, 4 liters, right? Is that correct?
Yeah.
Good job. And we're supposed to put them into how many cups? 10 cups. Wow. That's a lot of cups, isn't it?
Yeah.
All right, as you can see, we have 10 cups here. How much is going to go in each cup?
4 tenths. 4 tenths.
Well, it would be like 4 divided by 10, and as we've been doing it, we've been seeing the pattern is 4 tenths, right? So we could go ahead and put that in there. So each one is going to have 4 tenths. Now, what else did the problem ask? It asked you how much will be in each cup. Well, 4 tenths. Express your fraction as a decimal. Okay. Now, if you guys remember, we have our decimal, right? Do we have any whole numbers? No. So I'm going to put a 0 here. The first number is what?
4.
Tenths, isn't it?
Yeah.
And then the second number is hundredths, right? Question, which one of these are we going to be putting the 4 into? What's down below it? It's a 10. So we're going to put it in the tenths category, right? So that works out pretty well. We have 0.4. Then it asked us to give the milliliters. Is that correct? What is our answer for milliliters? Well, do you remember about when we talked about liters and stuff? Maybe we should review. We had a liter, right? Then we have a and then we have a centimeter, and then we have a milliliter. Is that correct? I put the wrong thing on. Why did I put an M there? What would we put this? Now, what do? Well, we fill in these with zeros, right? So this would be 0.4 is our answer, right? Isn't 0.4? Going to put a 0.4 here, and then what do I do with the other ones? I just fill it in. So my answer is 400 milliliters. That was pretty easy, wasn't it? Wow, we did liters a long time ago, didn't we?
Yep.
All right, well, my last problem I have, Jim is pedaling his boat for 3 days. He's traveling a total of 14 miles. How many miles did he travel each day? The question is miles, right? So what are we going to be cutting up? Are we cutting up days? Or are we cutting up miles? How many miles did he travel each day? So are we cutting up miles or are we cutting up days?
Miles.
We are cutting up miles. So our top number needs to be what then? 14. And then our stack tape diagram that we find easier than just a regular tape diagram. How many days? 3. So we have 14 divided by 3. How many 3s are in 14? Well, 3 times 1 is 3. 3 times 2?
6.
3 times 3?
9.
Have we reached it yet?
No.
3 times 4?
12.
And 3 times 5?
15.
Well, 15 is too much. So 4 would be correct. Is that correct? All right. So we could put in our standard algorithm. What number goes on the inside of the house? What number goes on the inside of the house?
14.
14, and the 3 goes on the outside. How many 3s are in 1? 0. How many 3s are in 14?
4.
3 times 4 is?
12.
Subtract.
2.
Leaves us with 2. 4 and 2 thirds. So as you can see, we get 4 and 2/3 for each one, right? All right. This is a nice check. It's a nice way to do it in the tape diagram. Because what if they said, hey, let's say that Julian was paddling his boat, but he only covered half the miles per day that Jim did. Julian was doing half. What's half of 4?
2.
What's half of 2/3?
1.5.
Nope. What's a half of 2/3? What's a half of 2? 1, and the 3 stays the same. So Julian only went 2 1/3 miles each day. Right? Now what if Julian went for twice as many days? Well, that would be how many boxes? We would have to have 6, wouldn't we?
Yep.
So we would have 2 1/3 in each box. Would he have gone the same distance? Yes, he would have. We haven't changed anything except the number of days and half the distance. All right, so that's how we do word problems. Don't get freaked out by it. Give it a try and think about things like, hold on, what are we cutting up? Are we cutting up what? Are we cutting up days or are we cutting up the miles? If it's the miles, then that goes in the top, the days, right? What if we're having liters of soda? Well, we have two liters of soda, then that means we actually have 4 liters total. Don't get fooled by these things. Draw it out if you have to, like I did. So whatever you're cutting up needs to be in the top box, okay? I love math!